All right, continuing on with this example, we're going to next find the z-score, but we're not going to use that formula that's there because that z-score shows up quite handily right on your calculator screen. So if you look at your the results after we ran that test, you will see a z-value reported there, and that z-value is negative 1.7804 when we round to 4 decimal places. For the p-value, again, the p-value is going to be there on your calculator, but we're going to make sure we explain what a p-value is because that is an important concept. A p-value is the probability that the sample data would be obtained if the null hypothesis H sub 0 is true. Okay, so how likely is it that we would have gotten that same sample data? So in this case, that 131 out of the 1,432 complaints would be about identity theft, if indeed it's true that 23% of all complaints in Alaska are for identity theft. Okay, well, how do you find the p-value for a one sample proportion test? Again, we've already got that. You run that test on your calculator. And so the p-value, and whenever you look and you're looking at, oh, my calculator just cleared out. Gosh darn it. Okay, when you look at that test and you run your results, it's not the p hat. Okay, notice there is a little p hat. So right below the z is a p-value. The p-value is the 0.0375, and that's the one that we want. Okay, so from calculator, you want the value of p, not the value of p hat. Okay, when we write a p-value, you actually do have to write out p-value. P by itself, remember, is the symbol for the population proportion. So you do need to write out p-value. All right, so now decide whether or not to reject the null hypothesis based on the level of significance for the test. All right, so when we were running our test, just to give you a little visual here, okay, we were doing a left-tailed test because our alternative hypothesis was that we were less than the value of 0.23. Okay, so we're going down here to the left. I'm going to do a little bit of shading in here real quick. Okay, and since we're testing a 5% level of significance, what we want to figure out is if the p-value, okay, what we just got, is in the shaded region, we reject the null hypothesis. Okay, so we reject the value of H sub 0. Okay, so for us, change colors here. Okay, the value 0.0375 is in that shaded region. It is smaller than 5%. So it is in that most extreme 5% to the left. Okay, so here, the p-value, let me try to rephrase that there. The p-value is in the shaded region. So we reject H sub 0. Sorry, my screen is really wonky today. Okay, we reject H sub 0. So what is our conclusion? We would say there is enough evidence to support the claim that identity theft makes up less than 23% of consumer complaints in Alaska. Okay, because we are rejecting the null hypothesis. Remember, the null hypothesis was it's 23%. We have evidence because our p-value, again, is in this like red zone, if you will. Okay, I know I colored it black, but I circled it red. It's in the red zone, so we have evidence to support the claim that in Alaska, it's really less than 23%. Okay, so let's take a look real quick. What if instead our level of significance would have been 1%? Okay, well, if that's the case, now when we have our region, okay, and we shade like our, again, our red zone, this time I'm actually making it red, okay, so 1% is down here. When we take a look at our p-value of 0.0375, notice that that p-value is not in that most extreme 1%. So in this case, since the p-value is not in the shaded region, we do not reject the null hypothesis. Okay, so what would our conclusion be? It would be exactly the same as up above, except we would say we do not have enough evidence to support the claim that identity theft makes up less than 23% of consumer complaints in Alaska. Okay, so if you do not reject the null hypothesis, that means you don't have enough evidence to go ahead and say you believe the alternative hypothesis. Okay, if you do have enough evidence, if you do reject H sub 0, the null hypothesis, then you're saying that yes, I do have enough evidence to say this historical data here that we've got, this 23%, that's no longer accurate. It is now less than that.